Hello guys, so this is a tutorial on how to install Arch Linux on your system, particularly on how to install Arch Linux with Windows already pre-installed. So this is going to be a dual booting guide on installing Arch Linux. As you can see here, we have a normal and regular Windows 10 installation inside VMware. Before we start, if you are running your installation on a hard disk, you must first make sure that your disk has been fully defragmented to allow for better shrinking. If you are running on an SSD, you can skip this step. Next, we open the file manager, right click on this PC, click on manage. This will open up the computer management utility. Then we go to disk management, right click on the partition you want to shrink. It will load up the volume shrinking utility, and then you specify the required size for your new partition. In this case, I will give it the size of 60 gigabytes, that is 61440 megabytes. Click on shrink, and then you will notice that there is an unallocated partition that has been formed inside your disk. Next, we are going to open our VM settings, the CD/DVD settings. Once it loads up, we are going to choose an ISO image. In our case, we are going to navigate to the folder where I have my Arch ISO installed, and then select my Arch ISO. And on the real world, you will probably have this flashed on your pen drive using Rufus or Balena Etcher. And click on OK here, and for your case, insert it into an empty USB drive slot. As you can see, our Arch ISO has been loaded, and next we are going to shut down or restart our system. In the case of this VM, I'm going to shut down so that I can power on to the firmware. Next, we are going to power on to the firmware, and then among the boot options, select the CD/DVD drive. As you can see here, we have our Arch ISO booted up, and I am going to select the first default option. So once we boot into the Arch ISO live environment, first we have to do is to check the keyboard layout. By default, the Arch ISO comes with US keyboard layout, and if your keyboard has a different layout, you can change it by using the load keys command specified by the keyboard layout. However, since I'm already using a US keyboard, I will not change this setting and let it go as default. Next, we type ls /sys/firmware/efi/efi-vars and press enter. And if this returns some folders and files, it means that we have booted into the UEFI boot mode, which is what we require. Next, we are going to list out the available network devices by using IP link command. If you are going to install Arch Linux using Wi-Fi, you are supposed to use the IWCTL utility. And inside IWCTL utility, you are supposed to use the command station device ID connect SSID name followed by enter, and after which you have to give your passkey to connect to the network. Next, to verify the network connectivity, we are going to run a ping test, and as you can see here, we have stable connection. Next, we'll open CF disk on the primary storage device, that is /dev/sda. Then we go down to the unallocated space and hit new. Set the partition size and hit enter, which will create a new Linux partition. Then we select write and then type yes to write changes to the disk, after which we can quit from the utility. Next, we list out our partitions using lsblk/dev/sda command. Here we can see that we have 5 partitions. SDA1 is our EFI partition, SDA2 is Windows Reserved, SDA3 is Windows C drive, SDA4 is Windows Recovery, and our SDA5 is our Linux partition. After which we format the Linux partition using mkfs.exe4/dev/sda5. By the way, you shouldn't get that partition was mounted warning. This happened to me because I was messing around with the partitions. Next, we mount the partition by typing mount/dev/sda5/mnt. After the partition is mounted, we can install Arch Linux into the partition by using pacstrap-i/mnt and the packages base, Linux, Linux firmware, a text editor nano, and sudo. Now, on the real machines, we also must install Intel U code for Intel processors or AMD U code for AMD processors, which will update the CPU microcode. Since we are on a VM, this is not required. We select the defaults and press Y to continue. Next, we need to generate the file system table. To do that, we type gen fstab-u/mnt and send the output to the file /mnt/etc/fstab. After that, we are going to change root. To do that, we are going to type arch chroot/mnt and specify the shell /bin/bash. Next, we need to set the time zone. For that, we type in ln-sf/usr/share/zoneinfo, then type the tab to find out all available regions. After we find the required region, type ln-sf/usr/share/zoneinfo/region, tab again to show time zones. In our case, we'll be using Asia/Calcutta, so we will create a symlink ln-sf/usr/share/zoneinfo to /etc/local time. Next, we sync our clocks using hwclock --sys-tohc command. Then we can check the date using date command. In this case, we have mismatched date and time due to Windows using local time instead of Unix time. After that, we need to set up our locale and language settings. For that, we edit the /etc/locale.conf file. Why is it empty? Oh wait, I'm sorry. This is the file we are supposed to edit later. Exiting out of it. The correct file to edit is /etc/locale.gen. And in locale.gen, we scroll down and uncomment the language and region you are in. In my case, I will uncomment en_in UTF-8. After that, we generate the locale using locale-gen command. Once the locale files are generated, now we edit /etc/locale.conf file. In the file, I'll put the command machine language and locale setting. Next line, lang equals en_in.utf8, or in your case, your locale setting. Next, we need to give hostname for our machine. To do that, we need to edit /etc/hostname file. In the file, I'll put the command hostname configuration, and then I'll use the hostname archvm. After giving our hostname, we need to set up our IP tables. For that, we edit /etc/host file. In the file, we add #IPv4 loopback, which is 127.0.0.1, tab localhost, IPv6 loopback address, which is 1:1 tab localhost, hostname configuration, that is 127:0.1.1 tab archvm.localdomain space archvm. Now we need to give our root password. For that, we type passwd. I give the password. I'll give root, confirming root. Now our password has been updated. Next, we need a networking and a Wi-Fi manager. For that, I install network manager by typing in pacman-s network manager. Check in the files, pressing Y to install. Next, we need a bootloader. For that, I am choosing GRUB. So, to install GRUB, we type in pacman-s GRUB. Along with that, we need OS prober to detect other installed OSs, EFI boot manager, NTFS 3G so that we can read other NTFS formatted drives in Linux. After GRUB is installed, we need to check lsblk to find the EFI partition. Then create an EFI directory in /boot folder. Then we need to mount the EFI partition to the boot folder. In our case, we mount /dev/sda1 to /boot/EFI. Next, we install GRUB by typing in grub-install --target equals x86_64 EFI --bootloader ID equals GRUB, then --EFI directory equals /boot/EFI and the parameter --removable to allow for disk swap remodification. After GRUB is installed, we generate the GRUB configuration file by typing grub-mkconfig-o /boot/grub/grub.cfg. After that, we can exit out of the share root environment and also unmount the mounted partitions. After that, we can shut down or reboot. Here I will shut down so that I can power on to the firmware to modify the boot settings. Now I will power on to the firmware and go and change the boot order. Here I will change the order so that the machine boots first into the internal SATA hard disk instead of the Windows boot manager so that it can boot into GRUB. Depending on your BIOS, you may have to also do this step. After logging in as root, the next thing we need to do is to set up swapfile. For that, we do dd if equals /dev/0 of /swapfile ps equals 1m count equals 5121 status equals progress. To enable hibernation, we must create a swap file of size at least 1 GB more than the RAM size. Here I have 4 GB, hence 5120 plus 1 MB of swap file. If you are not planning to use hibernation, the swap file can be smaller or avoided altogether if you have 16 GB or larger RAM. Now we set up swap on the swap file. So we type mkswap/swapfile swap on. No, wait, I forgot. chmod 600/swapfile to set the right permissions. mkswap/swapfile again. After that, swap on/swapfile. Then we edit the fstab file to add the swap file mount. In fstab, we add /swapfile none swap defaults 00. By the way, I forgot to mention that we can connect to Wi-Fi using NMTUI utility. Oh wait, damn, I forgot to enable the network manager in the live session. So I'll type in systemctl enable network manager and systemctl start network manager to start it. Now we can use the NMTUI utility to connect to Wi-Fi. But since we are on a VM with Ethernet, we can skip this step. Next, we need to add a user. For that, we type user add -m-g users -G wheel -s/bin/bash for the bash environment. And I forgot to give the username. So let's redo this again, this time by giving the username Linosh. Now we need to give password for this user. So pass wd Linosh, let it be lkm, again lkm. Now we need to update the sudo doers file. For that, we type editor equals nano vi sudo. Then scroll down and uncomment %wheel all equals all and save and exit. Now we can exit out of the root login. Now I'll log in into my user account. Next, we need to install audio and graphics services for our desktop environment. For that, we are choosing the new kids in the town, Pipewire and Wayland. To install Pipewire, I'm going to choose the packages Pipewire, Pipewire-Alsa, Pipewire-Pulse, and Wayland as a display compositor. Then the desktop environment. There are plenty of choices here such as KDE, Plasma, XFCE, LXQT, Budgie, Cinnamon, i3WM, DWM, etc. In our case, we'll go with GNOME and GNOME Extras for the GNOME desktop environment. We select the defaults and press Y to continue. After GNOME is installed, next we'll install base level utilities. Now we'll install AUR helper, which allows us to automate the builds of Arch user repositories. To install, first we must git clone the build files from https://aur.archlinux.org and then /a.git. Oh, sorry for the typo, it is .git, not /git. After the build files have been downloaded, then we navigate into the clone folder and type make pkg-si to build it. Do note that ArchWiki generally discourages the use of AUR helpers as there is a chance that the automated building process could use the incorrect flags and thereby provide an incorrect builded result. Yeah, we will press yes to install the required dependencies. Next, we need to install the video drivers. For NVIDIA users, they must install the package NVIDIA and NVIDIA utils. Also note that NVIDIA does not have stable support for Wayland as of this recording of this video. And if you have NVIDIA GPU, you should prefer x.org instead of Wayland. For those who are using AMD graphics, if your GPU is older than GCN architecture such as HD 76000 series and older, you should use XF86 Video ATI. And if you have a GCN architecture card such as HD 77000 series and above, you should use XF86 Video AMD GPU. Regarding Intel drivers, there is the package XF86 Video Intel. However, the use of this driver is discouraged and it is better to use the kernel mode setting driver because it is known to cause instability. However, if you have hardware acceleration issues, you can install this package. Also important to note is that if you are running hybrid graphics, XF86 Video Intel must be installed for full switchable graphics functionality. Since we are in a VM, we will install OpenVM tools. Also, we will install XF86 Video VMware and XF86 Input VM Mouse for VMware video and mouse drivers. Next, we will install Plymouth, which allows us to have animated boot screens. Along with that, we will install additional theme Plymouth Theme Arch logo. We select the defaults. After that, we set the theme. Next, we need to add Plymouth hook to the kernel. For that, we need to edit /etc/mkinit/cpio.conf file. In the file, inside the modules section, we can preload the graphics drivers here. i915 for Intel, Radeon or AMD GPU for AMD graphics, etc. Since we are in a VM, we will ignore this. Then we'll go down to the hooks session and add Plymouth hook just after udev hook. Now rebuild the kernel image by typing sudo mkinit cpio-p linux. GRUB on Arch is a very verbose bootloader that shows a lot of boot messages. To suppress those messages, we'll install GRUB Silent, a silent version of GRUB. Do note that this package takes a lot of time to build, approximately around 10 minutes. Similar to what we did at 10 minutes 29, we need to reinstall GRUB with the same parameters. Next, we'll enable GNOME Desktop environment with Plymouth enabled by typing in sudo systemctl enable gdm plymouth. After that, we can reboot. Starting the machine up again. Don't worry about the boot screen. That's a bug I noticed on virtual machines. So once the login screen is ready, we'll log in. The VM is quite laggy because I haven't started the VM tools D service, so I'll open up a terminal and type sudo systemctl enable VM tools D, and I made a typo doing that, so retype. Type once again. God, I got type. Finally, we got it working. So next we'll start the service. And once you start the service, you'll notice that the resolution has changed to the right screen resolution. Next, I'll install pamac AUR, which is a graphical AUR helper. Now, once you open pamac, you will see that it states that no packages are found. To solve that, you should reinstall Arch Linux app stream data. Now, if you reopen pamac, you will see that their packages are found. So we have solved that issue. Now, if you want additional support such as snap or flatpak, you can reinstall pamac using the pamac-all package. Oh, I forgot to mention, to get AUR and Flatpak and Snap support on pamac, you should enable them in the third-party section in the preferences. The reason for specifically installing Chrome GNOME shell package is so that we can install shell extensions using Firefox and extensions.gnome.org. In GNOME Extensions, I'll install and configure the following extensions: GS Connect for Android integration, Dynamic Panel Transparency for top bar transparency, Desktop Icons NG for desktop icons, Tiling Assistant for better window tiling features, Hibernate status button so that we can get Hibernate and Hybrid Sleep options on the power menu. One amazing extension that is currently work in progress for GNOME 40 is -doc. So, to get the extension, we must first go to Evelish's GitHub page to download the build files for the GNOME 40 version of -doc. And here, we download the source code as zip, extract the zip, and before we start building, first we need to install SASSC as this extension requires it to compile, so it is one build dependency. Next, we need to make some changes in the location.js file to prevent the extension from lagging in Wayland. The fixes required are put in description. After making the required changes and fixes, we can install the extension by typing in make, after that make install. Do note that we must log out and log in again for the extension to start working. Next, if you want to make GRUB more presentable, you can install GRUB2 themes such as this one right here. So I will download this and install this. If you had removed packages that you don't need, you will mostly have unused dependencies. To remove these unused dependencies, you can open the terminal and type in a-yc. Now you see we have a good theme for GRUB. So that's all for the Arch Linux side. Next, I'll boot into Windows to show that it has no side effects from installing Arch Linux. As you can see, Windows is perfectly fine. So that is it for this tutorial, guys, and all the links required will be in the description. And if you love this video, please like and subscribe. And thank you for watching this video.